Have you ever wondered if the science fiction of Skynet could become our reality? Not the world-ending kind, but a vast, interconnected network where machines understand and interact with our world, just like we do. Well, we might be on the cusp of that future, and it all starts with something called OpenClaw. This isn't just another robot, it's a revolutionary leap forward in AI and robotics, a system designed to give machines something they've never truly had before: memory. Think about how you navigate your home. You remember where the coffee maker is, which drawer holds the spoons, and the path from your bedroom to the kitchen. You don't recalculate it every single time. This is because you have a persistent memory of your environment. Robots, until now, have mostly operated on a short-term basis. They see, they act, they forget. OpenClaw changes that entirely. It introduces a persistent memory system for robots, allowing them to build a lasting understanding of space, the objects within it, and the passage of time. Imagine a robot that doesn't just see a room, but remembers it. It knows the chair is usually by the window, that the book you were reading is on the table, and that you moved the plant yesterday. This is the power of OpenClaw. It's a framework that allows a robot to record its experiences in a rich, multisensory format. What it sees, what it hears, what it touches, and store it all in a long-term memory bank. This isn't just about mapping a room. It's about creating a living history of the robot's interactions with its environment. The robot can then query this memory, asking questions like, "Where did I last see my owner's keys?" Or, "Has this box been moved since I was last here?" This is a fundamental shift from simple navigation to genuine spatial and temporal awareness. So how does this technological magic actually work? Let's dive into the core components. One of the key technologies is something called spatial RAG, which stands for Spatial Retrieval Augmented Generation. Let's break that down. Retrieval augmented generation is a popular technique in AI where a model, like ChatGPT, retrieves relevant information from a database before generating an answer. This makes its responses more accurate and fact-based. Spatial RAG applies this concept to the physical world. The robot's memory acts as the database. When the robot needs to perform a task, it doesn't just rely on its immediate sensor data. It queries its entire history of spatial experiences to find the most relevant information to guide its actions. It's like having a perfect photographic memory of every place it's ever been. To make this massive amount of real-world data searchable, OpenClaw uses a process called voxelization. Think of a voxel as a 3D pixel. The robot scans its environment and converts the physical space into a grid of these tiny cubes. Each voxel contains a wealth of information: what color it is, what object it's a part of, when it was last seen, and so on. This turns a complex, ever-changing environment into a structured, searchable database. It's like turning the world into a digital library that the robot can read and understand. By combining 3D vision, language models, and this voxel-based memory, OpenClaw creates what its developers call a spatial language model, or SLM. It's an AI that doesn't just understand words, but understands what those words refer to in the real three-dimensional world. Now, this all sounds incredibly futuristic, like something straight out of a research paper. But the most exciting part about OpenClaw is that it's not just theory. It's already being put into practice, controlling real-world, state-of-the-art hardware. We're seeing the OpenClaw framework integrated with some of the most advanced robots on the planet. Take the Unitree G1, for example. This is a sophisticated humanoid robot capable of dynamic movement and interaction. With OpenClaw as its brain, the G1 isn't just executing pre-programmed routines. It's perceiving its environment, understanding commands in natural language, and using its memory to perform complex tasks with an unprecedented level of autonomy. It's not just about walking around either. The level of fine motor control is astonishing. We're seeing OpenClaw power incredibly dexterous robotic hands, capable of manipulating objects with human-like precision. Imagine a robot that can remember how to assemble a complex piece of machinery, not because it was programmed to, but because it watched a human do it and stored that process in its memory. We're also seeing it implemented on more accessible hardware, like the Nero arm from Nubility, which brings this advanced AI capability into a more compact and versatile form factor. This demonstrates the scalability of the OpenClaw framework. It is not tied to one specific robot, but is a universal brain that can be adapted to different bodies and different tasks, from large-scale humanoid robots to smaller, specialized arms. The applications are mind-boggling. In manufacturing, a robot could learn a new assembly process simply by observing a human worker, then replicate it perfectly, and even teach other robots. In logistics, a fleet of warehouse robots could coordinate with each other, remembering the location of millions of items and dynamically optimizing their routes based on past experience. And in our homes, a personal assistant robot could learn our habits and preferences, proactively helping with chores, finding misplaced items, and truly becoming a part of the household. This is the transition from robots as tools to robots as partners. They aren't just following commands, they are learning, remembering, and adapting. This brings us to an even bigger, more transformative idea, the concept of a machine economy. What happens when these intelligent, memory-equipped robots are not just isolated individuals, but are connected in a vast network? The creators of OpenClaw envision a future where robots have their own digital identities, their own wallets, and the ability to interact and transact with each other. Imagine a scenario where your personal robot needs a specific tool it doesn't have. It could broadcast a request to the network. Another robot, perhaps a specialized delivery drone, could respond, negotiate a price for delivering the tool, and carry out the transaction, all without any human intervention. This is a decentralized economy run by machines, for machines. In this machine economy, a robot's value would be determined by its skills, its knowledge, and the data it has accumulated in its memory. A robot that has expertly mapped a complex environment or has learned a rare skill would be more valuable. Its data and experiences become assets that it can trade or sell. This creates a system of incentives for robots to learn, explore, and become more capable. It's a powerful and slightly daunting vision, one where economic activity extends beyond the human realm into a world of autonomous, intelligent agents. The long-term implications are profound. This technology has the potential to fundamentally reshape our economy, our society, and our daily lives. The creation of a universal operating system for robots, one that gives them memory and a deep understanding of the world, could accelerate the deployment of robotics in every sector. It could solve labor shortages, increase productivity, and unlock new possibilities for exploration and discovery from the deepest oceans to distant planets. Of course, this also raises important ethical questions that we as a society will need to address. How do we ensure these systems are safe, reliable, and aligned with human values? How do we manage a world where autonomous agents are making economic decisions? The journey is just beginning, but frameworks like OpenClaw are laying the critical groundwork. They are bridging the gap between the digital world of AI and the physical world we inhabit. They are giving machines the one thing they've been missing to become truly intelligent: the ability to remember. The future isn't just about smarter algorithms. It's about creating embodied intelligences that share our world and our reality. What we're witnessing is not just an incremental improvement in robotics. It's the dawn of a new era, the era of the remembering machine. And it promises to be one of the most exciting and transformative chapters in human history. Thank you so much for joining me on this deep dive into the future of robotics. If you found this as fascinating as I did, make sure to hit that like button, subscribe for more content on cutting-edge technology, and let me know in the comments what you think the first thing a robot with a perfect memory should learn is. I'll see you in the next one.